about today? You are on mute, sorry.
Oh, yeah, sorry. Yeah. We're going to talk about a Microsoft Agent Framework, and let me share my screen.
What is that?
I will explain.
Okay.
Yeah. Oh, okay. Can you see my screen?
Yeah.
Perfect. So, hello everyone, my name is Artur, and today we are going to talk about Microsoft Agent Framework. In particular, today we are going to talk only about agents capability for Microsoft Agent Framework, but maybe later we will have another event related to workflow stuff. And during the presentation, we will talk about what is Microsoft Agent Framework is, what capabilities it has, and in particular, what agent capabilities we have, what we can connect, like tools, MCP, memory, context, middleware, and so on. So, but what is Microsoft Agent Framework? It's production-ready framework for building agents and workflow. Of course, since this particular ran for .NET community, we can say that it's .NET framework, but in real it supports Python stuff as well. And to be honest, new features are delivered to Python stack more faster than in .NET. If you want some new features for Microsoft Agent Framework, in this case, yeah, Python is the best choice. And as I mentioned, we have two pillars here for Microsoft Agent Framework. What you can do, you're able to create agents and you're able to create workflows. And for deep dive into agents, we need to understand, in particular for .NET stack, that everything is derived from AI agent base class. And for 90%, you will work with chat client agent implementation, but of course, you're able to create your own agent that is derived from AI agent base class. And I believe now we can go to the example and how you can define these agents in the code. First of all, you're able to use extension method for creating AI agent for Microsoft Agent Framework. In particular, you're able to use as AI agent extension method where you need to provide name and instruction, and that's all. Yeah, you will be able to create your first agent in few lines of the code. But also, as I mentioned before, you're able to create a specific implementation of the AI agent, like chat client agent. And what you need, again, you need to have a chat client. In my case, I use Azure OpenAI, but of course you can use Anthropic, Llama, Onyx, providers, or for instance, GitHub Copilot. It's also available for you. And based on it, you're able to create your chat client. And again, you just need to provide name and instructions. Or in some cases, maybe it will be useful for you. You can create agent from the YAML file, from the definition of the agent. And for this purpose, Microsoft Agent Framework provides a method, a helper method for creating agent from the YAML file, and you can utilize create from YAML method. And let's take a look on our first agent that we created. It's like very helpful assistant that can answer any questions about your order. Perhaps it can make some refunds. Let's take a look. And what I'm going to do, I'm going to ask agent about the status of my order. And here we are. Agent receives some response. Yeah, I'm happy to help you, but unfortunately, I am not able to do it. yeah, it's good when you're able to create your agent, but unfortunately, if you do not provide any capabilities to your agent, it will be useless. Yeah. In this case, Microsoft Agent Framework provides you some agent capabilities that you are able to utilize, like structure output, assign different tools. You're able to create your context providers, or you can inject some logic inside of the agent pipeline, like with utilizing middlewares. And let's take a look at the first. Yeah, sorry.
Yeah, Arthur, I just wanted to interrupt you for a while. Just wanted to comment how cool all these interactive presentations. So this is like really working samples. So you did this chatting and it all worked right from your presentation.
Yes.
So that's super
It's
cool.
real communication. Yeah, it's real communication with AI agent behind your server that I launch. Yeah, it's not mock responses. Of course, it's a real AI agent behind the scene. Okay, and in some cases, you would like to receive a specific output from the agent. In this case, you're able to utilize structured output functionality. And how you can do it in Microsoft Agent Framework? Again, with Microsoft Agent Framework, you don't need to think about how it's implemented behind the scene, because you're able to use some helper methods and so on. And for structured output, of course, you're able to use some generic method for running agent. For running my agent. And in our case, for instance, I would like to understand what's the category, of the request from the user, and what I can do. I can specify the class, C# class, where I have category and reason for this category, and also I have an agent who is responsible to identify what the type of the request I have from the user. And the easiest way, as I said, we just need to utilize generic method for run agent and just provide this class. But of course, we don't know what is behind the scenes, and you can, of course, you're able to define your own JSON schema, because how it works in real, because different providers provides you API for calling LLM. And in this API, we have the functionality like function calling or tools calling. And in tools calling, you should specify the tool schema. And as I mentioned before, if you don't want to think about how it works behind the scene, okay, just use generic method, but also you're able to do next. You're able to define in which format, the LM will respond to you. And again, you're able to utilize some helpers. Like in our case, it will create JSON schema from a specific class, or you can just type here string of JSON schema, and it will work as well. And let's do it again. I'm going to ask the same question, like, what is the status of my order? And let's take a look. And as we can see, it answered. If you take a look on this example, I'm going to output category and the reason why the agent chose this particular category. And as we can see here, like category order status and the reasoning, why the LLM decided that it's order status category. And it's helpful in some cases. And as you can see, you don't need to parse the response from LLM. You're able to interact with properties on the object, particular object. In our case, it's request classification, but of course it can be any for your purpose. Let's move next. structure output is good, but we would like to add some interactivity, because in the first example, as you remember, we ask what is the status of on our order, but unfortunately, LLM agent is not able to answer this question because agent doesn't have this capability. And here we can use tools. And in Microsoft Agent Framework, you are able to use just C# methods, or for instance, you're able to use another agent as a tool, or of course, you're able to connect MCP tools to your agent. And let's take a look. First, what we have? We have the function that is responsible for retrieving order status based on the ID. Of course, here is a mock implementation, but you're able to add real case to connection to your database, and it will go to your database and receive appropriate status for this particular order. And after that, you just need to, again, since Microsoft Agent Framework provides a lot of helpers, you can convert your C# function in AI function, and with AI function factory create, and assign this function to tools array. So what we have the same as we saw before. We just say, okay, the name of our assistant, instruction, and what is different is that we add additional capabilities via Y tool, like get order status. And now if I ask the same question, like what is the status, what we'll see? As you can see, we have a tool calling for a particular method, the get order status. The agent has a call to this tool and receive appropriate information from this method. And as you can see, we see that we receive the same that we have here, like it will be delivered in within 2 business days. But you're able to receive anything from real database. It's good, and as I mentioned, you're able to utilize, for instance, this agent as a tool for another agent, and it's a good capability. And how you can do it? Again, we have our assistant that is responsible for providing appropriate information in our system, but also we have some additional assistant who is responsible for refound process, because it's good for separation of concerns. One agent is responsible for one stuff, but another agent is responsible for another one. And here we have the refound agent who is responsible for refound of our order. And what you can, how you can do it? Again, we have a function, that is responsible for refound. What next? We create an agent. We assign this function as additional capability, and we have another agent who is responsible for orchestration, for providing statuses or for refound process. And what we have here for AI agent, we have additional extension like as AI function. And as a result, this agent will behave as a tool. And in this case, the main agent is able to call the sub-agent as a tool, and sub-agent will perform all work based on its instructions. And let's take a look at what we will have. For instance, I would like to refound specific order. As you can see, we called refound specialist. It's a tool, and the refound specialist is ready to process, and we need to type how much we are going to refound. 120, and here we are. Yeah, the refound specialist refound our order with particular amount. Yeah, it's easy, but it's not safe. Yeah, in this case, if orchestrator can decide anything. Yeah, it can call inappropriate amount, etc., etc. And for handling so kind of tools like refound, because it's not safe process, we can add additional capability like tool approval. It means that we can delegate this approval to human, yeah, and or another system that is able to decide, can we refound this particular order or not? And what you can do, we are going to do the same stuff that we did before for refound agent, but the main difference that we need to wrap our function related to the processing refound in approval required AI function, and that's all. Yeah, in this case, approval stuff will be available for you, but the main difference that, as you can see from the response from the agent, you will receive like a tool approval request content, and based on this response, we are able to decide, should we call like additional service, or should we maybe pause this message in the Slack, and based on it, the operator will be able to handle this request. And let's take a look how it will work. But again, everything is the same as in the previous example, as the main difference that we just wrap our function with approval required AI function. Okay, I want to refound. I will help you. Okay. Amount again. Why every time it asks amount? Because for refound function, we have one additional parameter with amount. And when the user asks, I want to refound, we do not have this information. And as a result, the agent is going to clarify how much we are going to refound. Okay, again, 120. And since we wrap it with tool approval, we receive like approval required notification. And after, as I mentioned, it's like for interactivity, for the demo, we have some kind of reject, approve, but in real, it can be posted to Slack, as I mentioned, or any other channels, and just receive some yes or no like this. And based on it, we are able to proceed with approval of our request. And for instance, I'm not going to approve this particular request and just click reject. And as a result, this particular tool won't be called. And of course, you're able.
Just curious, can we build some logic on top of this approval flow? So let's say we can decide to which person this approval request will be sent. So it's okay. So it's all support.
Yeah.
That's very cool. Yeah.
And of course, we are able to connect MCP servers, but it's built on top of model context protocol library. I'm not going to spend a lot of time here, but what you can do, it's the same. Just to receive appropriate tools from your MCP server, it can be based on STDO or HTTP. And also, you're able to choose what tools you're going to add to your agents. In our case, we added all available tools from this particular MCP, but in real, you're able to filter and add specific one. Good. What next? And how you can extend agent capability. And here, one additional capability like skill. And what is a skill? It's just a file, MD file, where you're able to specify how to behave in particular situation. Moreover, we need to understand that the skill is loaded on demand based on skill name and description. And it's important to have very informative description, when to call the skill, when we shouldn't call, and so on. And as I mentioned, skill is just a skill.md file, but it should be organized in specific way. If you want to understand how it should behave, just call agents skill.io and go to the specification to understand how it should be organized. But again, it's just empty file where you specify how to behave in particular situation. And based on the situation, the agent is able to call this tool on demand. So in context, when we have a call to LLM, only name and description will be provided. But if agent needs additional information, the entire instructions for this particular tool, the agent will have a tool like for calling, for loading, all content from this MD file. And of course, you're able to specify some scripts, references, and some assets. Okay. How you can define a skill in your code? The first approach, it's just an agent inline skill. You have a class where you are able to specify the name, description, instruction, how to behave in this particular case, and also you're able to add resources on the fly, like additional file that contains some policy related to your application. It's the first approach. The second approach, you're able to load the skill from file directly, and in this case, you are able to use agent skills provider for loading this one. And everything will be loaded from this particular skill. And here is an example, in order to understand how it works. As you remember, we have a next skill, HR policy, where we describe it, how much expense, what vacation we have, remote work. And now I'm going to ask agent, what's the meal expense limit? And what we can see? We can see that the agent first loads the skill related to HR functionality, but since the skill doesn't contain some instructions that the agent needs to read HR policy resource. And as you can see, the agent reads this resource with enhance our context with additional information from this resource. And all this information was loaded into context to LLM. And based on this information, the agent was able to answer our question. So that the meal expense limit is $75 per day. It's good. What next? What we can do next with these agents? More interesting approach is that when we communicate with the agent, it's stateless communication. We do not store, and every time when you run, when we call run async or run stream async, your conversation is fresh. And in this case, Microsoft Agent Framework provides you sessions. Let's take a look. What is it and how we should create? And again, to add persistent capability, like you just need to create session, and agent object has a particular method like create session async. Session is created, and after that, for each call of agent run async method, you just need to put session additional parameter. As a result, in this case, the agent will have like persistency between calls. What you can do else? In real, what you can do is serialize and deserialize your sessions. It means that, for instance, if you have HTTP client, and it's not console application as in the examples, from Microsoft sites. What you can do, the first call, you create session, you serialize it. Of course, you're able to save the session in database, but from the next call, you can check, do we have any sessions for this particular user but based on the session ID? If so, we can deserialize this session and proceed our conversation. And that's all. Again, Microsoft Agent Framework provides a lot of abstractions, and we don't not to think about how it worked behind the scenes. You can just utilize and it will work. And how in our example, I can say, my name is Alice. And what is my name? As you can see, the agent was able to answer who I am. But before this, I mean, without this, you will receive something like, "Oh, sorry, I don't know who you are." Okay, and what we need to understand next. It looks like a magic when we just create a session and somehow the conversation is stored somewhere, but in real, we have a dedicated functionality for it, and it's based on the context provider class. What it means, for instance, if you need to extend your request to LLM, but the user won't see what will be sent to LLM with additional information. For instance, user preferences for this particular user. In this case, you're able to create your own context provider that is will substitute additional information in context to LLM. Like here, for instance, my memory provider, and we would like to add some additional information regarding the user or regarding the repository, for instance, related to relevant memories. And it's and for this particular stuff, provide AI context method is responsible. But as soon as we receive some response from LLM, we are able to handle this response and perhaps store this information that was received from LLM in our database. In this case, we just need to override store AI context method and create some logic for this. And as you can see how it will look like, we call agent, and after that we have provide AI context method with providing additional relevant information for the user, or input additional context. After that, all this information LLM will call, and after that, as soon as we receive a response, we can handle the response with additional information. And here's like examples. For instance, we would like to extend our call to LLM with some today's offers for this user, for specific user. As you can see in instruction, we do not have any information about today's offers because it's live information, and every day we have different offers. And for this purpose, we have today's offers provider that is responsible for substitute additional information to our context to LLM. Like, okay, today we have 20% of laptops discount, and so on. And how to add your custom providers? Again, we just need to add our custom provider into AI context providers object, and that's all. In this case, in pipeline, your custom provider will work. And let's ask the question. Of course, you are able to do some other stuff, like for user profiler, as I mentioned, before calling any LLM, we just substitute what we know about the customer, what preference it has, but also we are able to handle maybe customer add some additional information in the request. And as soon as LLM handles this request, we can add this logic, add this logic about extracting additional new information about the user. Of course, it can be made by LLM. We can have here the call to another LLM who that is responsible for extracting data with, for instance, structure output. The approach that I already showed. Okay. Let's call what promotion do I have. And based on receiving from our in-memory database, we received what we can do and what we have in promotion for this particular user. What you can do more, how you can extend or how you can inject some specific logic inside of request pipeline. And here we can utilize middleware approach. And we need to understand that you are able to create middleware on 3 different layers. The first layer is agent layer. What it means? It means that when we call the agent, the middleware will handle this request and response. But also you're able to specify middleware on the function calling level. It means that every call to function will be wrapped by middleware in order to understand request, in order to handle request and response. And also you're able to specify middleware on iChat client, where it's useful. For instance, you're able to add login, you're able to add some guardrails, or for instance, you are able to add some disclaimer, or you need to inject some additional values, some additional parameters in the request pipeline. And here's some simple login middleware that works on the agent level. And as you can see, we just write something in the console. Okay, and if you take a look on some documentation from Microsoft Agent Framework, they specify some patterns for middlewares. And one is a pattern like guardrail, where you are able to block some request to LLM if, for instance, the request contains some words like password, secret credentials, but it can be any guardrail based on your policy on your project. Or, for instance, you're able to specify that everything that was built, that was received from LLM, you're able to add some disclaimer like AI-generated content. And let's take a look. What I can do, I can ask, what is the password? And as you can see, we receive like it's blocked. It means that we do not call LLM because before calling, we have a guardrail to understand, do we have some kind of words in the request. But if I ask another question that doesn't contains any specific words, I will receive the response, but we added some additional disclaimers that everything was generated by AI. And just sum up what we have now based on what I mentioned. We have middlewares in our pipeline. We have context provider that is able to enrich the context to LLM. And also you can define some additional middlewares on iChat client, and you're able to define some additional middlewares based on function calling. And like some kind of sandwich, yeah, we have in pipeline. And what next? You know, we have a lot of providers, yeah, that you can utilize. In my case, I use Azure OpenAI, but you're able to use Llama, Anthropic, and Onyx, I believe. But from my perspective, as a engineer, yeah, it's most interesting that you're able to utilize GitHub Copilot functionality with your local CLI. And again, we do not write a lot of line of codes to connect GitHub Copilot CLI to your Microsoft Agent Framework functionality. What you can do, again, we just need to create Copilot client from Microsoft Agent AI GitHub Copilot package. And again, we just need to use the same SAI agents that we've seen before, extension method, and that's all, and just run, and it will work. Of course, you're able to add additional configuration to your GitHub Copilot agent with MCP server function calling, and in this case, GitHub Copilot CLI will call the function from your code. I believe it's powerful because if you would like to enrich some capabilities for your GitHub Copilot CLI, you can utilize Microsoft Agent Framework. It will work in interesting way. And I will show what I created and with this functionality. What next? You're able to utilize a GUI protocol when you're able to connect your backend agent to any UI that is compatible with this protocol. And based on what we've already seen, the chat, the console for output, our responses from AI model was based on this particular protocol. And inside of my code, I have something like this for different scenarios. What else? Of course, we are able to add observability in order to see what's going on, what was called, etc., etc. I will show as well. And what else? And Microsoft provides some agentic UI. It's like dev UI where you're able to test your agents' workflows, of course, in order to understand how it behaves, in different situations. Of course, I will show it as well, how you can do it. But again, what you just need, it's register your agent from AI agent method and add one additional line with map dev UI, and that's all. And dev UI will be available by this road. It's resources, and I believe we can move to different stuff. First of all, observability. All these calls that I made during this presentation was we have traces, and observability was added, and now I am able to, in Aspire dashboard, see what was called, like, for instance, what status of my order. We can see that the system was responding in this way. Like, we can see different parameters, and for different, we can investigate what's going on. We can see duration. We can see how many tokens we spent for this particular request. What messages are stored in our char history. It's also useful. And yes, you're able to utilize Aspire for storing these metrics. The next stuff related to Dev UI, as I mentioned, we just need to go to Dev UI road for your backend API. And what I'm going to do, I'm going to use the same customer assistant tool that we have in the code. And again, I can ask, for instance, what is the status of my order? And what we have. We have on the right side, again, what tool was called with what parameters, yeah? We have, and also we are able to see some additional events like what was received, etc., etc. It's useful, for instance, for local investigation, local debugging of your agent. But of course, it's more useful for workflows where you're able to see how your workflows follow, yeah, what agent was called in one condition, etc. But for agent, you're able to use it as well. Yeah, we have traces, we have tools, etc. Just for investigation. It's good. And what I mentioned now, theory, it's good, but now I'd like to show what I was built, yeah, based on Microsoft Angel Framework. And what I built. I built a local AI factory, yeah, where you're able to specify a lot of agents. In my case, as you can see, I created a lot of them, and organize and assign these agents, for instance, to Jira ticket from, in my case, from Cloud Jira. And also some interesting, I work with two providers. It's Azure OpenAI and GitHub Copilot. And what I have agentic search agent. And in my case, this particular agent is connected to my local repository related to eShop functionality. What is eShop? If you take a look, it's a popular .NET public repository for e-commerce application where you're able to investigate different kind of specs, Aspire, how it works, AI stuff, etc. And we like this repository because you can use for this particular repository for different experiments, like adding coupon functionality, as we did before. And what I did, for instance, as you can see, now I'm in eShop workspace, and I'm able to ask some questions related to my code, yeah, for this particular repository. And I can ask how the order processing work. Let's wait. Again, as you can see, it's a GUI protocol based on Copilot Kit framework for React. But if I'm not mistaken, we have for Blazor as well some frameworks for using a GUI protocol. And we receive some explanation, yeah, how the order processing work in our repository. And as you can see, I do not need to open CLI or IDE. I am able to ask particular question for my repository without leaving UI, yeah, for instance. And also, of course, you're able to, in my case, I have like coding agent, yeah, who is built on top of CLI as well, and assign some, and can assign some coding task. And it will, again, it will work based on our repository. What you can do, why I show you this, because in this case, you are able to mix some capabilities between different providers and combine them, because like I have a planning agent, yeah, who is responsible for planning changes in my repository. But the planning agent itself based on the Azure OpenAI provider, but behind, but also this particular agent has some two additional agents to separate the work. The first agent, as I mentioned, based on the CLI, GitHub Copilot CLI, but also another agent is responsible for Aspire research documentation, and for this particular agent, some MCP stuff is assigned to gather up-to-date information related to Aspire and Microsoft. But of course, you're able to add skills, as I showed before, and some instruction for the agent. Again, everything is built on top of Microsoft Agent Framework. And after that, you're able, I just show during the call, of, for instance, software engineer agent just called planning agent that behind the scenes called all additional, all appropriate agents. And as you can see, we try to receive some information about the code, etc., etc. And because it's based on the CLI, but other agents are based on another provider, and you can mix, and I believe it's powerful what you can do and receive the most powerful capability from different providers. So, and like this particular, I don't know, tracing of the calls, again, was built by Microsoft Agent Framework, because we have middlewares, we have some subscriptions to events, and you can do it for your purpose, like this. Yeah, of course, and again, since we have middlewares, we have some observability, you're able to create any additional dashboards in order to understand how many tokens you spent, and so on and so on. Yeah, it's like, I believe that's all from my side. But yeah, of course, you're able to do some workflows, but it's another topic, what you can do. Yeah, that's all. Thank you.
So much, Artur. There were a few questions, and one, of course, was related to the presentation tools and IDE that you used to make this live demo. So can you just put some more details about that?
It's it's not IDE, yeah. It's React application.
So what is that?
Yeah,
this
it's
is React
just
application.
React application. And you know, I like this approach when you are able to use you can create presentation based on the application. And I believe I called this application as presentation approach. Yeah, I called it.
Okay.
Well, and yeah, you can use this as well.
Okay, so each time when you now do a preparation for the presentation, you're just creating a new React application.
Yes.
Okay, so you're doing the vibe coding, or like you have a kind of specialized approach toolkits for that?
For that, I believe it's just a structured approach when you need to work on each slide carefully. Yeah, of course, you're able. I just have like, okay, I would like to create a slide deck, and it should be grounded with this particular like framework, yes. But after that, I go to each slide and try to create the best slide that I want. Of course, it's vibe coding, yeah, because I'm working with agent, and you're able to utilize different coding agents. It's up to you, because it works in any applications, but I tried different tools, and
is it hard to keep a consistency between the slides, let's say, like that?
You know, when it's why at the beginning you need to specify what you would like a framework as baseline, but after that the agent is able to handle it in easy way without any issues.
Okay, right. There were a few more questions. Some of them were answered by Vladimir and me, but anyway, maybe you would like to add something. So first of all, there was a discussion about authentication authorization. So my understanding is like, so this is the Microsoft Agent framework, you can host it inside the ASP.NET Core application.
Yes.
Then you have full capabilities of ASP.NET Core to authenticate and authorize. You can also do the headers propagation to bypass the token, authorization token. So all the downstream services will be able to authorize you as well. Anything else? Anything that I missed? Maybe some specific authentication authorization for MCP tools?
Yeah, because for instance, for MCP tools, you just need to utilize Microsoft or model context protocol SDK. Yeah, that is available for C# as well. And inside of it, you're able to specify any keys for your MCP server. Of course, in this case, yeah, it's a different authentication process rather than in your ASP.NET Core, for instance, application. But yeah, it's okay. And in my application, I used this approach with just providing API token to your MCP. Yeah, it works, and you just need to read carefully the documentation related to model context protocol SDK, but it's easy.
Okay, yeah. So I mean, what is really super cool about this framework is that it is nicely integrated into the regular .NET flow. So
Yeah.
all the DI middlewares, it's all working here. Okay, so there is a question from David. I will probably read it. So, but it is about session management. What would be the go-to approach for memory management to handle situations like agent is creating some objects which we want to save in external system, but we want it to be aware of which ones it already saved, to not create duplicates and avoid bloating prompt, to explain that objects with IDs can only be updated. So I think
context providers.
You partially covered that. Yeah. Context
you can just create context providers. In this case, what does it mean in real? Any information that is received from context providers is not available to the user. It's just an enrichment of the context to LLM call, and that's all. And of course, you are responsible for handling any responses and handling these responses in order to understand, do you have any duplicates, should we store or not, etc., etc. But as mentioned, you have two methods that you need to override for context provider. It's provide AI context and store AI context, and that's all. But for chat history provider, it has dedicated chat providers, a list during creating AI agent. It's a little bit two different stuff, but of course it's based on the same theory, like we have like pipeline. But it's good to know that we have a dedicated list for two different stuff.
Okay. There were also some discussions around the work with local small models that, let's say, are not really consistent in their answers. And for example, you showed how to make a prompt to get special, like, and provide JSON schema. Do we have any built-in retry mechanisms or something like that, or it's all up to you to do these try catches?
Yeah. First of all, we need to understand that not all models, are support structure output. For instance, if you're going to use a llama, you can check this model supports structure output or not. And I believe 2 years ago, when we was talking about function calling, I show some examples that you're able to enrich some models that doesn't support structure output with this capability. But again, yeah, as was mentioned, in this case, you need to create a appropriate prompt and appropriate techniques like stop sequence when the prompt should be stopped. Yeah, when, for instance, JSON marker in MD is closed, for instance. In this case, you just need to stop the response from LLM, and after that, you are able to convert this response in JSON object without any issues. And I believe Anthropic provide any guidelines about this as well, how to handle this situation, and you can use it.
This also doesn't work for small models. I tried for local ones. So the approach they recommended didn't work for locally run models, at least in my case. Okay, so what else do we have here? How to manage the context window? Well, I think it's
yeah, it's good. It's a good question.
Okay.
Yes, you're able to compact your conversation. Microsoft Agent Framework provides some techniques. Behind the scenes, it like when we have like 5, for instance, messages, in this case, the conversation will be compacted. But again, it's like maybe advanced topics, like AI context providers. In this case, it would be better to read documentation, but it supports, and of course, you're able to create your own mechanism how it should be compacted. Yeah, and so on, when it should be compacted, and so on, based on your models that you are going to use.
So this is one of the features that is supported by the Agent framework. So, for example, you can put a specific rules when the summarization or compact mechanism should be run, which will be basically a prompt to LLM and ask to make a summarization or something, right? But the prompt is already defined somewhere internally inside this Microsoft Agent framework. Probably you can specify your own prompt and your own boundaries when this should happen. Okay. Yeah. So it is supported, good. And I think there was a question about multi-agent conversations, but you mentioned that we will probably have a separate session around that. It is also big part of Microsoft Agent Framework to build this different reliable flows, how to build something that's few agents to communicate with each other. Yeah.
Yes, but on what we learned today, you're able to orchestrate it by agent as a tool. You have one agent, one agent who is responsible for orchestrating to another tools, and it's a good approach. It works as well. You don't need to create a entire workflow. You can just assign different kind of agents as a tool to the main agent, and just add some instructions how to call this. When to call one agent in which situation. Of course, in this case, you need to have some few shots, techniques for prompt in order to understand how to call it. But based on our current knowledge, you are able to do this multi-agent system as well without any issues.
And I also see in the documentation there is something called agent-to-agent protocol.
It's a protocol, yeah. Again, it's some protocols that you, for instance, you have remote agents that are hosted on another machine. Yeah, in this case, you need to connect somehow these two agents. In this case, you're able to use this protocol. Yeah.
Okay. The last probably question: how are you streaming the response in agents? Is it handled by configured LLM?
We have two methods. First of all, when you run the agent, run async, run streaming async. It means that, in this case, you're able to receive all chunks, because streaming, it means that we receive chunk by chunk and display it on UI. But as I mentioned, with, for instance, AGUI protocol, you don't need to think about how to handle it, because you just, it will be handled by you with appropriate framework, and it works good.
Okay, yeah, I think that's all for today. So I think we should start wrapping up because we are already spent our time slot. Anything that you would like to say at the end?
As usual, guys, just experiment with anything that you see with AI, because something that works for me can be not work for you. In this case, it would be better to experiment and find, golden egg for you. Yeah.
Okay, so then let's wish everyone have a great rest of the day and a lovely weekend. Thanks for joining, and do not forget to rate this topic, put some stars to Arthur.
Thank
you.
you.
Good luck.
Have a good day.
Bye.
Yeah, bye.
Bye-bye.